In this video, we're going to go over the main theorem on intervals of convergence. And this result says that a series centered at A converges in one of three ways. Okay, the first way is where the series converges on a finite interval centered at A, and the radius of convergence is positive. So going back to the example from the last video, where we're summing -1 to the n over n times x plus 2 to the n, we found that this series converges on the interval from -3 to -1. And here we're not including this left endpoint -3, but we are including the right endpoint -1. And note that this interval is centered at -2, which is the center of this series. And recall that the radius of convergence measures the gap between the center of the interval of convergence in either one of these endpoints. And so here the radius of convergence r is equal to 1. Okay, now more generally, in this first case, it's possible to have convergence at neither endpoint. It's possible to have convergence at the left endpoint, but not at the right endpoint. It's possible to have convergence at the right endpoint, but not at the left endpoint, like we have in this example. And it's possible to have convergence at both endpoints. Okay, but in every one of these scenarios, we're looking at a finite interval centered at A, and the gap between A in either one of these endpoints is this number r that we call the radius of convergence. All right, now the second way a series of this form can converge is where the series converges for all x. And we saw that with this example, where we're summing -1 to the n times 3x to the n over n factorial. We found that this series converges for all x. And note that here, the radius of convergence r is infinite. All right, now for the third way, all right, this is by far the most extreme and, well, uninteresting way a series of this form can converge. Okay, it's where the series converges only at the center, x equals a, and it diverges for all x not equal to a. We saw that with this example, where we're summing n factorial times x minus 3 to the n. Okay, this series converges only when x is equal to 3. But see, when I plug 3 in, I don't get a terribly interesting series. I'm just summing up a bunch of zeros. Okay, so I have convergence only at this single point when x is a. And if I deviate at all from a, then the resulting series is divergent. Okay, note also here that the radius of convergence r is equal to 0. All right, so now with all of this in place, let's go ahead and look at question 4. It's a good illustration of this theorem. So it says, suppose that the series of c sub n times x to the n converges when x is equal to -4 and diverges when x is 6. What can be said about the convergence or divergence for the following series? Explain. Okay, before we jump into any one of these parts, let's just unpack what we have from the given info. Okay, so a first note that this series is centered at a equals 0. Okay, so mark that here on the number line. Now the series converges when x is -4. I've marked that here in blue. And the series diverges when x is 6. I've marked that here in red. Right, now the fact that the series diverges when x is 6, that tells me that I'm not in scenario 2. In other words, the interval of convergence is not the entire real number line, right? Because of this divergence here at x equals 6. Okay, also, I'm not in scenario 3. Why? Well, because I have convergence at x equals -4, and my series is centered at a equals 0, right? Scenario 3 is where you have convergence only at your center point. Okay, so I'm not in scenario 3. So that puts us in scenario 1, where we have a finite interval of convergence, and our center is at a equals 0. Okay, and now note that since we do have convergence at x equals -4, that tells me that the radius of convergence, r, has to be at least 4. Okay, it can't be less than 4, because if it was less than 4, right, we wouldn't have convergence at -4. Okay, so r is greater than or equal to 4. And since we have divergence at 6, that tells us, well, the radius of convergence cannot exceed 6. Okay, so this divergence here at 6, that puts an upper bound on the radius of convergence. Okay, so now let's go ahead and describe what we're looking at for each one of these extremes. When r is 4, well, x equals -4 would be the left endpoint of our interval. Okay, and so x equals +4 would be the right endpoint. And based on our discussion just a few moments ago, right, well, we may or may not have convergence at this right endpoint. And so I just put a little question mark there. All right. Now, at the other extreme, if the radius of convergence is 6, okay, well, I know I have divergence is 6, so notice I put an open circle here. And since the radius is 6, x equals 6 would be the right endpoint of the interval, and so x equals -6 is the left endpoint. And again, since it's an endpoint, I don't know if I have convergence here, right? So I just put a question mark. All right, so now with all of this in mind, let's look at part A. We're looking at this series, right, where we're summing c sub n times 8 to the n. And note that this series, right, is the result of just plugging in x equals 8 here. All right, so x equals 8, well, that falls outside of the interval of convergence in each extreme. And so we can conclude that the series in part A, it must diverge. Okay, what about for part B, where we're just summing c sub n? Okay, well, this series is found by just plugging in x equals 1, and see x equals 1 is in the interval of convergence in each extreme. And so this series must converge. Okay, for part C, we're summing c sub n times 4 to the n, right? This series is the result of plugging in x equals 4, but we could be in this scenario, right, where the radius of convergence is equal to 4, and so 4 could be an endpoint to the interval of convergence, and we just don't know whether or not we have convergence there. And so we'll just say that the convergence can't be determined. Okay, and then for this last series, we're summing -1 to the n times c sub n times 6 to the n. Okay, and note that this series is the result of plugging in -6 in for x, right? Because -6 to the n is the same thing as -1 to the n times 6 to the n. And see, if x is -6, well, that could be an endpoint, right? We could be in this scenario where the radius of convergence is 6, and so we could be looking at this left endpoint, and again, we just don't know whether or not we have convergence, and so we cannot determine whether or not this series converges. All right, great. Well, that's a good place to stop. I will see you in the next video. Thanks.